Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, today our group would like to present about our project, which is about pressure in pipe. So, I introduce myself first. My name is Muhammad Syahmi bin Mualib. Okay, next. Okay, generally, our project, the objective of our project is to perform experiment and simulation about flow exercise in hose pipe. So in the hose pipe, we need to analyze the pressure variation in hose pipe over a specific pipe length with two different configuration. The two different configuration that I say is we have straight line and also closed loop. Next. Okay, the introduction about our project is what about our project is we need to create or find the way of watering the plants. So as I mentioned before, we have two types of pipe configuration. The first is straight line and also closed loop. Uh, the two pipe configuration give variation in terms of flow rate, volume of water received by each plant, because we have two different types, straight line and also closed loop. So when we water the plant, the amount of water, the amount of water spread out to the plant is different for each plant. And then lastly, it also affect the quality of the plant itself because of the amount of water spread out by the hose pipe in straight line or closed loop. Okay, next. We move to the equipment. So in the equipment, we have 3/5 millimeter single connector. We use for the straight line hose pipe, and then we have 16 millimeter T connector, which is we use for the closed loop hose pipe. Next. For the main body of the experiment, which is the hose pipe itself, we choose the 16 millimeter touch with 10 meter hose pipe for this project, and also we have hose clip to attach the hose pipe to the water pipe. Next. We have stopwatch. The function of the stopwatch is we record the time when the water spread out from the hose pipe itself. And then lastly we have the 500 ml measurement cup, which is we collect different volume of water regarding the two types of the hose pipe, which is straight line and also closed loop. Next.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sufian bin Mazlan. So for the experiment, I will explain. I will proceed for this presentation. So for the first experiment is the water jet. So for this experiment, we only measure the flow rate and the pressure of the water by close a little bit at the end of the hose, and then let the water spread to up, and then we will measure the height of the water maximally can reach. Next. So for the closed loop hose pipe, for this experiment, we will have a hose pipe, which is we have 7 millimeter. I'm sorry, 7 millimeter length in length, and then for the 10 hole, we divide by 7 millimeter. We create a hole, and then for this experiment, this one is closed loop, so we are using the T connector to connect end to end each other, and then we will open the tap water, and then we will measure the volume of the water each hole, and then we will record the time at the same time. So the data from this experiment are taken and jot down lah. Next.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Muhammad Mustaqim bin Rosman Rizal. Okay, I will continue to present on the third experiment, that's its straight line hosepipe with 5 holes. Okay, for this experiment, the length for the hosepipe that we use is 3 meter. Okay, we also have punch 5 hole on the hosepipe. Okay, and the distance between the five hole is 0.6 meter. And then as we can see on the picture, the water will flow out from the hole. And then the thing that we record from the experiment is like the 10 holes also. It's the same. We record the times and the volume for the liter of the water. Okay, then we move to the next slide. Okay, for the result and data, this is the result data that we record. And then for the length of the hose pipe for the water jet is 1.5 meter. And for the straight line 5 hole is 3.0 meter. And for the closed loop 10 hole is 7.0 meter. And for the times that we record, that we fix the time that's for the straight line 5 holes, and the closed loop 10 hole is for the 60 minutes. And the volume of water that we get for the straight line 5 holes is 0.25 liter. And for the closed loop 10 hole that we get is 0.5 liter. Okay, we move to the next slide. Okay, this is for the calculation for the flow rate and the velocity. The formula for the flow rate is volume times with 10 power of negative 3 divided by times for the velocity 4 times with flow rate divided by pi times with diameter power of 2. Okay, for the flow rate that we get for the straight line 5 hole is 4.167 times with 10 power of negative 6 meter cube per second. And the closed loop tensor we get 8.33 times with 10 power of negative 3 meter cube per second. And for the velocity we get for the straight line 5 holes is 40.7 meter per second, and the closed loop 10 holes is 29.4 meter per second. Okay, that's all. Next slide.
Okay, Assalamualaikum. My name is Nabil Aiman bin Alias. So I'm doing the simulation part. Basically, there is two simulation part for our experiment, which is 90-degree pipe and T pipe. So I'm doing the 90-degree pipe. So as we can see from the simulation, the dimension that I've done is 500 and 200 respective, and I'm put the dimension in the hole is 10 millimeter. And next, for the graph, so we can see the velocity. For the graph, you can see the velocity it's changed from x, y, and z axis. Okay, and next, okay, for the last one, there's the form change from the path line color by particle ID. Okay, next I will pass for the T degree pipe.
Hello, Assalamualaikum. Nama saya Muhammad Izzuddin Mahmota. I am doing ANSYS for T connector. Okay, this is a sketch for T connector. For the inlet, for the inlet, I use 4 millimeter diameter. For the length, I put the 37 millimeter. Next, this is a graph after the calculate on mesh. The graph maybe have something wrong on the sketch because the graph not like this. The graph must smooth like 90 degree connected 90 degree pipe. So the next, this is the flow on the floor in pipe. Like I say, the sketch mightly broken because the flow is not correct like this. The correct one is 90 degree pipe because the color on floor is fully. That's all from me.
Okay, so my name is Muhammad Syahir bin Ma'ruf. So for the discussion, we get our pressure and velocity are inversely proportional to each other. If pressure increase, the velocity will decrease to keep the sum of potential energy, kinetic energy and pressure constant. Okay, next. There are a few factors that affect the flow rate of water in the pipe. First, the diameter. In water flowing pipeline, pipe size and water pressure are dependent on each other. Because if the diameter of pipe decrease, then the pressure in the pipe will increase. So in narrower pipe, the velocity can be high and pressure can be higher. In a fluid passing through pipe, a reduction in diameter of the pipe can compress the flowing fluid. It will flow faster, which increase the flow rate. And if the diameter increase, then the flow rate will reduce. Next. Factor is also length of the pipe. The reduction in pipe length offer resistance against the flow and results in pressure loss. When the flow velocity increase, the pressure increase, and then efficiency reduce. And then bending the pipe will also affect the flow rate in the pipe. Turbulent flow occurs in bend section, making it difficult for fluid to flow. When this happens, laminar flow changes to turbulent flow and energy loss occur. Energy loss leads to lower pressure. Okay, that's all for me.
Okay, I continue with conclusion of our project. Throughout the experiment and simulation, we were able to apply the concept of mass, Bernoulli, and energy equation after we completed the project. Second, we have succeed on achieving the objective of the project, in which we want to find the pressure variation with two different ways of watering the plant, which is we have straight line and also closed loop. And then lastly, the pressure in hose pipe can be analyzed with variation ways, as I mentioned before, over a specific pipe of length such as 7 meter and also 3 meter. Okay, That's all from our group. Thank you.